9th of January, 1941. A cold morning at Woodford Aerodrome near Manchester. Roy Chadwick stood on the frozen tarmac, watching his creation prepare for its maiden flight. The 4 Rolls-Royce Merlin engines coughed to life one by one. Their combined thunder shook the ground beneath his feet. Inside the cockpit sat test pilot H.A. Brown, known to everyone as Sam. He advanced the throttles. The propellers bit into the winter air. The aircraft began to roll. Chadwick held his breath. Everything depended on the next few minutes. His career, his reputation, perhaps even Britain's survival. The twin-engine Manchester bomber he had designed 2 years earlier had been a catastrophic failure. Unreliable engines, inadequate power. Pilots called it a death trap. Of the 193 Manchesters built, 78 were lost in action. Another 45 crashed due to engine failure alone. That was a loss rate no Air Force could sustain. The Air Ministry had nearly fired Chadwick, nearly canceled his entire design team, but Chadwick had refused to give up. He had taken the Manchester's fuselage and made one radical change. Instead of 2 massive Vulture engines, he fitted 4 smaller Merlins. The wingspan stretched from 70 feet to 102 feet to carry the extra weight. Everything else remained largely the same. It was a desperate gamble. And now, as Sam Brown lifted the nose and climbed into the gray January sky, Chadwick would learn if his gamble had paid off. The aircraft flew like a dream. Brown later reported that it handled better than any bomber he had ever flown. Responsive, stable, powerful. The 4 Merlins provided 6,480 horsepower combined. That was more than enough to lift a fully loaded aircraft into the sky. More than enough to carry bombs deep into Germany. More than enough to change the war. That aircraft became the Avro Lancaster, and over the next 4 years, it would deliver more bombs than any other bomber in history. It would breach dams that German engineers swore were indestructible. It would drop earthquake bombs that tunneled underground before exploding. It would fly 156,000 sorties and deliver over 600,000 tons of bombs. Germany had no answer for it, nothing that could stop it, nothing that could match it. The Lancaster was Britain's answer to the question that haunted Churchill's war cabinet. How do you hit back at an enemy that seems invincible? The story of the Lancaster begins with failure. Spectacular, expensive, deadly failure. In the mid-1930s, the Air Ministry issued specification P-1336. They wanted a new twin-engine medium bomber to replace Britain's aging bomber fleet. The specification called for an aircraft that could carry 2 18-foot torpedoes internally. It needed to fly worldwide. It needed to make shallow, dive-bombing attacks. It was an ambitious request. Perhaps too ambitious. Roy Chadwick and his team at A.V. Rowe & Company responded with the Manchester. The design looked impressive on paper. A sleek twin-engine bomber powered by 2 of Rolls-Royce's newest engines, the Vulture. Each Vulture produced 1,760 horsepower. That sounded like plenty of power. But there was a problem. The Vulture was essentially 2 smaller engines bolted together into one massive X-configuration 24-cylinder monster, and it had never been properly tested. The Manchester prototype flew for the first time on the 25th of July, 1939, less than 6 weeks before Germany invaded Poland. The test flights revealed problems immediately. The Vulture engines overheated constantly. Bearings failed. Connecting rods broke. Entire engines would simply seize up mid-flight. Pilots reported that losing one engine meant almost certain death. The Manchester couldn't maintain altitude on one Vulture. It could barely stay in the air, but Britain was desperate. The war had started. Bombers were needed. Production was ordered before the problems could be fixed. The first operational Manchester squadron formed in November 1940. Within months, the aircraft's reputation was in tatters. Crews refused to fly it. Squadron commanders sent angry reports to the Air Ministry. The Manchester was killing more British airmen than German flak. On the 13th of April, 1941, all Manchesters were grounded. Too many bearing failures. Too many crashes. They were grounded again on the 16th of June for the same reasons. Squadrons had to keep flying obsolete Hampton bombers because their brand new Manchesters couldn't be trusted. It was a humiliating disaster, a waste of precious resources, a failure that cost lives. Chadwick knew the problem wasn't his airframe design. The problem was the engines. Rolls-Royce had rushed the Vulture into production before it was ready, and now men were dying because of it. But complaining wouldn't solve anything. Chadwick was an engineer. Engineers solve problems. He started sketching. What if instead of 2 unreliable Vultures, he used 4 proven Merlins? The Merlin was Rolls-Royce's masterpiece. It powered the Spitfire. It powered the Hurricane. It was reliable. It was powerful. And it was already in mass production. Chadwick calculated the numbers. 4 Merlins would produce more power than 2 Vultures. The wingspan would need to increase dramatically to carry the extra engines, but the fuselage could stay mostly the same. The tail assembly could stay the same. The bomb bay could stay the same. It was an elegant solution. Take a failed aircraft and fix its one fatal flaw. The Air Ministry was skeptical. They had just suffered through the Manchester debacle. Why should they trust Chadwick again? But they had no choice. Britain needed heavy bombers. The Germans were bombing London every night. Churchill demanded retaliation. The only way to strike back at Germany was through strategic bombing, and for that, they needed bombers that could actually reach German targets and return home safely. Chadwick received permission to build 2 prototypes. He worked around the clock. His design team worked in shifts. Every hour mattered. Every day Germany continued bombing British cities was another day Britain fell further behind. The prototype was ready in less than a year. That's why Sam Brown found himself climbing into an untested aircraft on that cold January morning in 1941. After Brown's successful first flight, more tests followed. The prototype exceeded expectations in every way. Maximum speed of 280 miles per hour. Service ceiling of 23,500 feet. Range of 2,700 miles with a minimal bomb load. But the most impressive specification was the bomb load itself. The Lancaster could carry 14,000 pounds of bombs. That was more than the American B-17 Flying Fortress, more than the B-24 Liberator, more than any other bomber flying in 1941. The Air Ministry ordered immediate production. No more delays, no more tests. They needed Lancasters now. The first production Lancaster rolled off the assembly line in October 1941. By February 1942, the first operational squadron was formed. Number 44, Squadron at RAF Waddington received their Lancasters with a mixture of relief and hope. Relief that they wouldn't be flying Manchesters anymore. Hope that maybe, just maybe, this new aircraft would let them fight back effectively. The Lancaster's first operational mission was on the 3rd of March, 1942. 4 aircraft laid mines in the Heligoland Bight. It was an unremarkable mission, routine, almost boring. But that was exactly what made it significant. All 4 aircraft returned safely. No engine failures, no catastrophic mechanical problems. The Lancaster worked. After the Manchester's litany of disasters, that simple fact was revolutionary. Throughout 1942, Lancaster production ramped up rapidly. More squadrons converted from obsolete bombers to Lancasters. Crews trained on the new aircraft. Tactics evolved. The Lancaster's true capabilities began to reveal themselves. That massive bomb bay could accommodate weapons that other bombers couldn't dream of carrying. The unobstructed length stretched 33 feet. Engineers could fit almost anything inside it. This versatility caught the attention of a brilliant engineer named Barnes Wallis. Wallis worked for Vickers. He had been developing a radical idea, a weapon to destroy German dams. Not just damage them, destroy them completely. The dams in Germany's Ruhr Valley held back millions of tons of water. That water powered German industry. It cooled German steel plants. It provided drinking water for German cities. If you could breach those dams, you could cripple German war production. But the dams were massive, thick concrete structures designed to withstand earthquakes. Normal bombs bounced off them harmlessly. Wallis had a solution, a cylindrical bomb that would skip across the water like a stone. The bomb would bounce over the torpedo nets protecting the dams. It would sink right against the dam wall. Then it would explode underwater. The explosion would focus all its force against the dam in a phenomenon called the cumulative effect. The pressure wave would crack the concrete. The dam would fail. Millions of tons of water would flood the valley below. The theory was sound, but it required a bomber that could carry a 9,000-pound cylindrical bomb. A bomber that could fly at exactly 60 feet above the water at exactly 232 miles per hour. A bomber with a bomb bay big enough to accommodate a mine 4 feet in diameter and 5 feet long. In 1943, only one aircraft met those requirements, the Lancaster. Wing Commander Guy Gibson was selected to lead the mission. Gibson was 24 years old and already a veteran of more than 100 combat missions. He was tasked with forming a new squadron specifically for this operation. Number 617 Squadron, Gibson handpicked his crews. He wanted the best pilots, the best navigators, the best bomb aimers. He got them. These men would need every bit of skill they possessed for what came next. Training began immediately. The crews practiced low-level flying. Night after night, they screamed across the English countryside at rooftop height. Farmers complained about the noise. Local authorities reported dangerous flying. Gibson ignored them all. His men needed to be perfect. One mistake at 60 feet altitude would kill them instantly. They practiced over reservoirs. They practiced over lakes. They practiced until flying at 60 feet in complete darkness became second nature. Meanwhile, Barnes Wallace perfected his bomb. He called it Upkeep. The weapon was a masterpiece of engineering. A steel cylinder filled with 6,500 pounds of Torpex explosive. The bomb would be mounted transversely in the Lancaster's bomb bay. Before release, it would be spun backwards at 500 revolutions per minute using a hydraulic motor. The backspin would make the bomb skip across the water. Without the spin, it would simply sink. The engineering tolerances were incredibly tight. Everything had to work perfectly. The Lancasters themselves needed modification. The bomb bay doors were removed entirely to accommodate the large cylindrical bomb. Spotlights were fitted under the nose and tail. When both lights converged on the water surface, the aircraft was at exactly 60 feet altitude. A special sight was developed for the bomb aimer. When two prongs lined up with the dam's towers, the aircraft was at exactly the right distance for release. Everything was measured. Everything was calculated. Nothing was left to chance. The target date was set for mid-May 1943. The moon would be full. The reservoirs would be full from spring snowmelt. Conditions would be perfect. On the 16th of May, the crews received their final briefing. They learned for the first time what their target was. The room fell silent. Men looked at each other in disbelief. Breach German dams with bouncing bombs. It sounded impossible. Suicidal. But Gibson and Wallace had worked out every detail. The crews trusted their commander. They trusted their aircraft. They would do their duty. At 9:28 that evening, 19 Lancasters took off from RAF Scampton. 133 men were aboard. They flew in 3 waves. Gibson led the first wave of 9 aircraft. Their target was the Mona Dam. The aircraft flew low across the North Sea to avoid German radar, so low that spray from the waves occasionally hit the propellers. They crossed into German airspace, still flying at wave-top height. German radar operators never saw them coming. The first aircraft reached the Mona Dam just after midnight. Gibson made the first attack run. He lined up his Lancaster at exactly 60 feet. The spotlights confirmed his altitude. His bomb aimer watched the towers through his special sight. Wait. Now. The bomb dropped away. Still spinning at 500 revolutions per minute, it hit the water and bounced. Once, twice, 3 times. It struck the dam wall and sank. Gibson counted. 10 seconds. The charge exploded. A massive column of water shot 500 feet into the air, but when it settled, the dam held. The second Lancaster attacked. Same procedure, same result. A huge explosion, but the dam stood firm. German flak gunners in the dam towers were firing now. Tracer rounds filled the air. The third Lancaster attacked. Pilot Flight Lieutenant Hopgood pushed through the storm of flak. His Lancaster was hit. Fuel streaming from the wing. The bomb dropped but bounced over the dam and exploded on the far side. Hopgood tried to climb away, but his Lancaster exploded. Only 2 of his crew escaped. The fourth Lancaster attacked. Pilot Flight Lieutenant Martin held his nerve despite the flak. His bomb struck perfectly. Another massive explosion. Still, the dam held. The 5th aircraft, piloted by Flight Lieutenant Maltby, made its run. His bomb hit the dam just as Martin's explosion subsided. The cumulative effect of multiple explosions was working. Cracks appeared in the concrete. Gibson circled and watched. Then, at precisely 12:56 a.m., the Mona Dam broke. A section of the dam wall, 77 yards wide and over 100 feet deep, simply disintegrated. Water exploded through the gap. Millions upon millions of gallons cascaded into the valley below. The flood wave was 12 feet high when it reached the town of Neheim, 6 miles downstream. It destroyed everything in its path: factories, houses, roads, bridges, all swept away. Gibson led the remainings aircraft to the Eder Dam. This dam was even more difficult to attack. It sat in a valley surrounded by hills. The approach required diving down over a hill, leveling off at 60 feet, dropping the bomb, then pulling up sharply to avoid the far hillside. It was a maneuver that left no margin for error. The first 2 attempts missed. The third, Lancaster, piloted by Pilot Officer Knight, made a perfect approach. His bomb breached the dam. Another wall of water thundered down the valley. Of the 19 Lancasters that took off that night, 8 failed to return. 53 men died. 53 out of 133. That's a loss rate of nearly 40%. But the mission succeeded. The Möhne and Eder dams were destroyed. The Ruhr Valley was flooded. German industry was disrupted for months, and the world learned that Germany's vaunted defenses could be breached by British bombers carrying revolutionary weapons. The Dam Buster raid made the Lancaster famous, but it was just one mission among thousands. The Lancaster's real contribution to the war was its steady, unglamorous, night-after-night bombing of German cities and industrial targets. Between 1942 and 1945, Lancasters flew more than 156,000 combat sorties. They delivered 608,000 tons of bombs. That's more tonnage than any other Allied bomber type. More than the American B-17, more than the B-24, more than the Halifax, the Lancaster's British stablemate. The Lancaster could carry bombs that other aircraft couldn't touch. In September 1943, Barnes-Wallis developed a new weapon called the Tall Boy. It was a 12,000-pound bomb designed to penetrate deep underground before exploding. The shock wave from a Tall Boy detonation could collapse tunnels and bunkers. It could crack the foundations of massive concrete structures. Only the Lancaster could carry it. In March 1945, Wallace perfected an even larger version called the Grand Slam. 22,000 pounds of bomb, nearly 11 tons. It was the largest conventional bomb of the entire war. A Lancaster had to be specially modified to carry one. The bomb bay doors were removed, some armor was taken out, even the nose turret was removed to save weight. But it worked. Lancasters dropped Grand Slams on German U-boat pens, viaducts, and command bunkers. The bombs penetrated up to 40 feet underground before exploding. Nothing could withstand them. The Germans tried desperately to counter the Lancaster offensive. Night fighters prowled the skies over Germany. Radar-guided flak batteries filled the air with shrapnel. Searchlights swept the darkness looking for bombers. The Luftwaffe developed the upward-firing cannon installation called Schräge Musik. German night fighters would sneak underneath British bombers and fire upward into the undefended belly. Hundreds of Lancasters fell to these tactics. But the Lancaster kept coming. Production ramped up throughout the war. A.V. Rose factories in Manchester worked around the clock. Victory Aircraft in Canada built Lancasters under license. Armstrong Whitworth, Vickers Armstrong, and Metropolitan Vickers all produced Lancasters. At peak production, over 230 Lancasters were rolling off British assembly lines every month. Germany simply couldn't shoot them down fast enough. The survival statistics for Lancaster crews were grim. Bomber Command required air crews to complete a tour of 30 operations. A mathematical analysis showed that at the average loss rate, a crew had less than a 44% chance of surviving their first tour. Some operations were far deadlier than average. The raid on Nuremberg on the night of the 30th and 31st of March, 1944, cost 96 bombers out of 779 dispatched. 545 airmen died in one night. That's more than the entire 4-month Battle of Britain, but the men kept flying. New crews arrived at operational squadrons fresh from training. They looked at the empty beds in the barracks and knew their chances. Some lasted 1 mission, others lasted 5. A lucky few survived 20 or even 30 operations and completed their tour. A handful of extraordinary men like Wing Commander Guy Gibson and Group Captain Leonard Cheshire volunteered for additional tours. They flew 40, 60, even over 100 missions. The odds should have killed them. Yet somehow they survived. The Lancaster itself was remarkably resilient. The structure could absorb tremendous punishment. Lancasters returned from missions with massive holes in wings and fuselage. Some landed with one engine completely shot away. Others flew home with hydraulic systems destroyed, landing gear damaged, and control surfaces riddled with shrapnel. The aircraft had a reputation for bringing its crew home, even when badly damaged. This wasn't luck. It was good design. Chadwick had built redundancy into every system. Critical components were protected by armor. Fuel tanks were self-sealing. The Lancaster was designed to be survivable. Compared to its British stablemate, the Halifax, the Lancaster had clear advantages. The Lancaster was faster by 25 miles per hour. It could carry 9,000 pounds more bombs. Its bomb bay was unobstructed, allowing it to carry oversized weapons like the Tallboy and Grand Slam. The Halifax couldn't match these capabilities. However, the Halifax had its own advantages. It was structurally stronger. In a crash landing, the Halifax tended to break into sections, which often saved the crew. The Lancaster's fuselage was more likely to collapse completely. Statistically, Halifax crews had slightly better survival rates. But when it came to destroying targets, the Lancaster was superior. The Air Ministry's Commander-in-Chief of Bomber Command, Sir Arthur Harris, despised the Halifax. He called it inadequate. He wanted Lancasters and only Lancasters. He pushed production facilities to build more Lancasters even at the expense of Halifax production. Harris was ruthless in pursuit of his goal. He believed strategic bombing would win the war, and he believed the Lancaster was the weapon that would make it happen. Harris's faith in the Lancaster was vindicated time and again. When precision targets needed to be destroyed, Harris sent Lancasters. When maximum bomb tonnage needed to be delivered, he sent Lancasters. When special weapons like the bouncing bomb or Grand Slam needed to be dropped, only Lancasters could do the job. The aircraft's versatility was unmatched. One of the Lancaster's finest hours came in November 1944. The German battleship Tirpitz had been hiding in Norwegian fjords for years. The ship was a constant threat to Allied convoys. Previous bombing attempts had damaged but not sunk the massive warship. On the 12th of November, 32 Lancasters from No. 9 and No. 617 squadrons attacked Tirpitz with Tallboy bombs. Flying from northern Scotland, the Lancasters found their target in perfect weather conditions. They dropped their 12,000-pound Tallboys from high altitude. At least 2 scored direct hits. One Tallboy penetrated the ship's armored deck and exploded inside. Tirpitz capsized and sank with the loss of around 1,000 men. The Lancaster had accomplished what battleships and aircraft carriers had failed to do. Throughout 1944 and early 1945, the Lancaster offensive intensified. German cities burned under the weight of British bombs. Dresden, Hamburg, Berlin, Cologne. Night after night, hundreds of Lancasters flew into German airspace. German industry was systematically destroyed. Oil refineries, factories, railroad yards, communication centers, everything that kept the German war machine functioning became a target, and the Lancaster delivered destruction with ruthless efficiency. By the spring of 1945, German air defenses were collapsing. The Luftwaffe had lost too many experienced pilots. Fuel shortages grounded much of the remaining fighter force. Flak batteries ran short of ammunition. Lancaster loss rates dropped significantly. Missions that would have been suicidal in 1943 became almost routine in 1945. Bomber Command had won the night battle over Germany. When the war in Europe ended on the 8th of May, 1945, Lancaster production stood at 7,377 aircraft. Of those, 3,349 were lost on operations. That's a loss rate of 45%. Nearly half of all Lancasters built were destroyed in combat, but they had done their job. They had delivered over 600,000 tons of bombs onto German targets. They had forced Germany to divert enormous resources to air. Defense. They had destroyed German industry and disrupted German logistics. And they had demonstrated that Britain, standing alone for much of the war, could strike back at the heart of Nazi Germany. The Lancaster's success was built on Roy Chadwick's brilliant design, but it was also built on the courage of the men who flew them. 7-man crews working in cramped, cold conditions at 20,000 feet, surrounded by darkness, hunted by night fighters, shot at by flak, knowing that statistically they probably wouldn't survive their tour. Yet they strapped in and flew mission after mission because someone had to, because their country needed them, because stopping Nazi Germany mattered more than personal safety. Bomber Command lost 55,573 men during the war. That's more than the combined losses of British officers in the First World War. It's a casualty rate of 44%. Nearly 1 man in every 2 who served in Bomber Command died. They died in burning aircraft over Germany. They died when flak shells exploded in their cockpits. They died when night fighters shot them out of the sky. They died when their damaged bombers crashed on returning to England. The Lancaster gave them the best possible chance of survival and mission success, but it couldn't make them invincible. The Lancaster served beyond the war's end. Some were converted to transport aircraft. The Avro York and Avro Lancastrian variants carried passengers and cargo. Lancaster transports flew relief supplies into Berlin during the Soviet blockade in 1948 and 49. Other Lancasters were converted for maritime patrol duties. The Avro Shackleton, derived from the Lancaster, served with the Royal Air Force until 1991. That's 50 years after the Lancaster's first flight. Today, only 2 Lancasters remain airworthy. One flies with the Battle of Britain Memorial Flight in England. The other flies with the Canadian Warplane Heritage Museum. Both aircraft are cherished symbols of Britain's determination during its darkest hour. When they fly at air shows, crowds fall silent. The sound of 4 Merlin engines is unmistakable. It's the sound of history, the sound of courage, the sound of young men who flew into terrible danger because their country asked them to. Roy Chadwick didn't live to see the Lancaster's legacy fully appreciated. He died in a plane crash in August 1947. He was only 54 years old, but his creation lived on. The Lancaster proved that good engineering could turn failure into triumph. The Manchester had been a disaster, but Chadwick had taken its failures, learned from them, and created one of the most successful bombers in history. He had turned Britain's most urgent problem into its most effective solution. The secret order that built the Lancaster wasn't a single dramatic decision. It was a series of choices. The choice to give Chadwick another chance. After the Manchester failed, the choice to use 4 proven engines instead of 2 unreliable ones. The choice to push the aircraft into production quickly, despite limited testing. The choice to trust the design even when the statistics said most crews wouldn't survive. Each choice compounded on the others. Together, they created something extraordinary. Germany had no answer for the Lancaster because Germany couldn't build an equivalent aircraft. German bombers were smaller. They carried fewer bombs. They couldn't reach deep into enemy territory and return. Germany's industrial capacity was focused on fighters and ground attack aircraft. By the time German engineers tried to design a 4-engine heavy bomber comparable to the Lancaster, it was too late. The resources weren't available. The time had run out. Germany's bomber force had been relegated to defensive duties and eventually grounded completely. The Lancaster represented British engineering at its finest. Not flashy, not revolutionary, just solid, practical, effective design. It took proven components and assembled them in the right way. It prioritized reliability over innovation. It focused on doing one job extremely well, rather than attempting multiple roles adequately. The bomb bay was massive because carrying large bombs was the priority. The defensive armament was adequate but not excessive because speed and altitude were better defenses than guns. Every design decision served the central purpose: get to the target, drop the bombs, come home. That simplicity of purpose made the Lancaster deadly. German industry learned to fear the sound of Merlin engines in the night. Workers in German factories knew that when the air raid sirens wailed and the searchlights stabbed upward, Lancasters were coming. And when Lancasters came, destruction followed. Buildings would collapse. Fires would rage. Production would halt for weeks. There was no defense that stopped them all. No night fighter force large enough. No flak battery dense enough. The Lancasters kept coming. The psychological impact was immense. German civilian morale suffered under the constant bombing. German workers couldn't produce effectively when they spent every night in air raid shelters. German industry couldn't function when factories were repeatedly destroyed. German transportation couldn't move supplies when rail yards were cratered. The Lancaster didn't win the war alone, but it made Germany's defeat inevitable by destroying the industrial base that sustained the Wehrmacht. After the war, strategic bombing remained controversial. Did it shorten the war significantly? Did the civilian casualties justify the military gains? These questions are still debated by historians, but what's not debatable is the Lancaster's effectiveness at the mission it was designed for. It delivered more bombs with greater accuracy than any other British bomber. It gave RAF Bomber Command the tool they needed to take the war to Germany when no other option existed. In 1940 and 41, Britain couldn't invade Europe, couldn't fight German armies directly, but it could build Lancasters and send them east every night. And that mattered. The Lancaster story is ultimately about people responding to desperate circumstances. Roy Chadwick facing professional ruin after the Manchester disaster, choosing to try again with a modified design. Sam Brown climbing into an untested prototype and trusting it would fly. Guy Gibson handpicking crews for an impossible mission and training them to perfection. Bomber command crews strapping into their aircraft night after night, knowing the odds were against them. Factory workers building Lancasters around the clock. Ground crews maintaining the aircraft in all weather. Everyone playing their part. The Lancaster emerged from this collective effort as something greater than the sum of its parts. It was aluminum and steel, engines and propellers, bombs and fuel. But it was also courage and determination. It was Britain's refusal to surrender. It was the answer to the question of how you fight back when you're alone and outmatched. You build the best weapon you can, you train the best crews you can find, and you strike at the enemy's heart until he can't fight anymore. Germany had no answer for the Lancaster because the Lancaster was built by a nation fighting for survival. It embodied British resolve in physical form. Every rivet, every weld, every hour spent at the drafting board or on the assembly line, all of it focused on a single purpose: strike back, make them pay, show them they can't win. The Lancaster did that better than any aircraft before or since. It was the secret weapon Germany couldn't counter, the bomber that changed the war, the aircraft that proved Britain would never quit. When the last operational Lancaster was finally retired in 1954, it marked the end of an era. The age of propeller-driven heavy bombers was over. Jets were the future, but the Lancaster's legacy endured. It had shown what British engineering could accomplish under pressure. It had proven that yesterday's failure could become tomorrow's triumph. And it had carried thousands of brave young men into the darkness over Germany to do a job that had to be done. For that alone, the Lancaster deserved to be remembered, not as a weapon of destruction, but as a symbol of determination. The aircraft that Britain built when everything depended on getting it right.